Hi students, a very good morning to everybody. Last session we had discussed a chapter called Units and Measurements. We have not finished that. We are in the starting part of this session. Chapter. Look at this. So far we have discussed this part. In SI system of units, there will be 7 fundamental or base physical quantities. See, do not get confused with the word called fundamental or base. Both are same. Which among the following is a base physical quantity? That means which among the following is a fundamental physical quantity? No confusion at all. And 2 supplementary physical quantities are also there. Last class we had completely focused on these 7 fundamental physical quantities and the unit name of them and the symbol of them. In this session, we will be focusing on the 2 supplementary physical quantities. I have just named them in the last class. Now, we will be discussing in detail about them, and the majority of the class will be based on the dimensions of these physical quantities. What exactly meant by the dimensions also we will be learning, right? Now, let's quick recap the previous thing. 7 fundamental physical quantities are there. The fundamental quantity means the quantity which is independent of any other physical quantity. That's called fundamental physical quantity. Clear? You know the derived physical quantities also. I'm not talking about derived physical quantities. We are completely concerned about the fundamental quantities now, right? So the first quantity is the length, whose unit name is meter and whose symbol is m. Next, mass, its unit name is kilogram and its symbol is kg. Time, unit name is second and symbol is S. Electric current, unit name is ampere, its symbol is A, capital A. You should be more focused on the small letter and capital letter here. Here you can see small m, small k, small s. Here also small m, small k, small s. No capital M written here. Electric current, unit name is the name of the scientist. Yes or no? See, meter, kilogram, second is not the name of the scientist. Understand? If anybody watching this class having the name meter or kilogram or second, you just message me in the WhatsApp. These are not the names of the scientist, but ampere is the name of a scientist. Understand? Clear? Now, as it is the name of the scientist, I can say the symbol is capital A. And we will be discussing about the rules of writing units, rules of mentioning units now. Just after finishing this. Wait for a while. Only focus on small letters and capital letters in this unit name and the symbols. Let me come back. Thermodynamic temperature, its unit name is Kelvin, and you can see I have started with a small letter K and the unit symbol is capital K. It's a capital value, K. Luminous intensity, its a unit name is, see here, candela. Symbol is CD. Okay. Now, amount of substance, mole. Symbol is small mol. Plane angle, these are the 2 supplementary physical quantities. Plane angle, it's a radian. Symbol is RAD. Solid angle, its unit name is steradian. Its symbol is SR. Okay. Now, dimensions we will be discussing later, just after few seconds, after few minutes. Listen. Before going to the dimensions, what we are going to do is some small rules of writing units. Rules of writing units. Okay. Number one, the first two. Simple. Units must not be mentioned in plurals. That's it. For example, a mass of an object is 10 kilogram. It's correct. So I cannot write mass of an object is 10 kgs. So this is wrong because plural I have used here. Kilograms, seconds, meters. And that's wrong. Newtons. No. Right? So I can say force acting on a body is 20 Newton. That's it. It's not 20 Newtons. Understand? That's correct. And second unit. Let's come to the second rule. Simple. Second rule. There are only three basic rules I'm telling you. Second one. Let's take the second rule from here. It's so simple. Here you can see Newton is the name of the scientist. Yes or no? When your unit is named after a scientist, that means if the name of the unit is the name of the scientist, so Newton is the scientist's name, then you can write the force is equal to 20 Newtons. If you want to write the symbol of the unit with a single letter, it must be the capital. Okay. If I write F is equal to 20 small n, it's wrong. If you want to represent this name of the scientist as a unit with a single letter, it must be the capital. What is that? It must be the capital. Understand? If you want to write a complete name, you should start with a small letter. You should not write like this. You can see 1 Newton. Force acting on a body is 1 Newton. This is wrong. You must write F is equal to 1 small n. You must start with small n if you want to write the complete name. So this is right and this is wrong. Another unit also you can take. So electric current is 1 ampere. Understand? Electric current is 1 ampere is given. Is it correct? Ampere is the name of the scientist. Understand? A must be small because we are writing the complete name of the scientist as a unit. I hope you're getting the point. So it is correct. Can I write electric current passing through the wire is 1 ampere? Can I write like this? No, right? Impossible. It's wrong. What is the correct one? 1 ampere. It is correct because if I want to represent the unit symbol with a single letter, it must be the capital because it's the name of the scientist. You got the point? Everyone? Clear? Now, the third one is so simple. If you want to mention the 2 letters, for every unit it's not possible. For example, pressure. You know the pressure acting on a body is equal to 20 Pascal. SI unit of pressure is what? Pascal. Okay. So this is how you should mention. If your unit symbol is having 2 letters, if it is a name of the scientist, you must write the first letter as a capital 1. Okay, clear? But if you want to write the complete thing, it will be like 20 small. Everything is small. 20 Pascal. Okay, so like this. So many other physical quantities also you will get later. Remember, 2 things I would like to tell you in this chapter. 2 things. Number 1. Related to this, 99% of the cases, the people who are studying physics will try to follow these rules. A 1% case, Our aim is not to become an accurate physicist. Our aim is to become trying to score maximum in your NEET exam, KCET or JEE exam. Right? For us, for time being, if you write electric current passing through the wire is 1 ampere, nobody will come and punish you, remember. But according to the physics, the mentioning of the unit in this way is wrong. That's it. Nobody will punish you. Understand? And even in the board exam also, they will not deduct the mark if you write the unit in this way. Nobody is going to deduct the score, remember. As this is the chapter is about the physical quantities and the units and the symbols, we are discussing in detail without leaving any single point. I hope you understand the importance of this one. Try to be accurate. That's it. It's not compulsory that you should do it this way. So many things you need to focus, not on these things. Clear? Now, and the second point. Second point in this chapter, we will be dealing with the physical quantities. There will be some physical quantities which you have not yet come across. Let me tell you one physical quantity called coefficient of viscosity, right? So let me write somewhere here so that you will get an idea. See here. Coefficient of viscosity, right? So first time you may be listening to this physical quantity. And another physical quantity I'll tell you. So magnetic flux or electric flux. So this is the physical quantity you may be listening to it now. Or another physical quantity, let's take induction. Magnetic induction. So this is maybe the physical quantity you will be listening first time. You will be coming across first time. But these type of physical quantities also we will be discussing in this chapter. I hope you understand. So these are the physical quantities. First time you are listening and understanding, do not go into the deep level of magnetic induction now, because the magnetic induction topic will come in the 12th standard in-depth analysis. Whatever the level is required, we will be learning there, but not now. As we are dealing with the physical quantities, and you should know what all the physical quantities and how we can apply the physical quantities and the units and their dimensions. Understand? Do not go into the deep of this one. Just try to learn the formula of that. Try to remember as maximum as possible the formulas of those physical quantities which you are coming across first time in your physics. Clear? We cannot avoid it because we are talking about the physical quantities. That's the reason we have conducted the basic foundation physics classes for so many classes. Right? Now, come back to the dimensions. In-depth analysis of the dimensions we will be learning soon. But now, length dimension will be like this. Square brackets. Every dimension of a physical quantity we will be representing in the square brackets in this way. Length dimensions will be like this. Capital L in the square brackets. Mass dimensions will be capital M in the square brackets. I'm telling you once again, any dimension of a physical quantity will be kept in a square brackets. Time dimension will be T. Electric current dimension will be square brackets A or electric current, right? Square brackets I. No confusions. Thermodynamic temperature dimensions will be square brackets K R square brackets theta. Luminous intensity dimensions will be square brackets candela. Amount of substance dimensions will be square brackets mole, MOL. Okay, clear? Now, plane angle, solid angle will have no dimensions. Okay, my dear students. So what was the last discussion is, angles will not have any dimensions. Why they will not be having any dimensions, we will be conducting when we will be discussing soon. Now, come back to the concept of plane angle and solid angle now. First, the plane angle. Plane angle is denoted with the symbol theta, but you should not get confused with this theta and that theta. This is the theta is representing thermodynamic temperature, and this is the theta is plane angle, and this theta will comes under thermodynamics, which is a branch of physics. And this theta we are discussing in overall physics, especially in circular motion, in mechanics. Clear? Or we can say especially in rotational motion, which is a branch, a chapter in physics, we will be discussing it. What is this plane angle? So simple. Imagine, so there is a particle moving in a circular path, and its radius of the circular path is small r. And this is the center, and the particle is starting from here. Imagine the mass of the body is m. After some time, the position of the particle is here. Okay. After some time. At this point also I can draw the radius r. Right? And it's clearly visible that there is an arc. Length of the arc. Imagine the length of the arc is L. Alright? And this angle made by the arc at the center is theta. Okay. And there is a formula for the plane angle. Plane angle theta is equal to length of the arc by radius of the circle. Right? So what is that? Length of the arc divided by radius of the circle. That's it. Length of the arc by radius of the circle. That's called the plane angle. L by R. What is L? Length. What is its unit? What is its unit? Meter. What is R? Radius. What is the unit of the radius? What is the unit of the radius? Meter, because radius is also a length from the center to any point on the circular path. Any point from the center you take, that's a radius, and the radius is also equal to the length. And you see this ratio, length by length, meter by meter, units will get cancelled. The theta will not have any unit. A physical quantity which is not having a unit will never have the dimensions. Understand? Clear? If there is a unit, there will be a dimension. Understand? So the symbol is there. Radian, steradian. It's a unit. Radian, steradian. But the ratio, as these two are the lengths, theta will not have any dimensions. Right? As this is a supplementary quantity, it is having just the unit name. Right? Alright? In reality, when it comes here, meter by meter is cancelled and there is no unit is observed here in terms of fundamental quantities. Now, solid angle, let's come back here. a solid angle. It's so simple. Solid angle is denoted with the symbol d omega. What is that symbol here? Its symbol is omega. See, I'm writing here. It is omega. It's a Greek symbol, omega. Solid angle is so simple. You need to imagine a football or a watermelon. Exactly the spherical shaped watermelon or football in spherical shape. Imagine it's not a hollow sphere, it's a solid sphere. Inside also the material is there. That's the reason I told imagine a muskmelon or watermelon exactly in the spherical shape. You cut towards the center from the top in this way. Right? You cut with a big knife from the top to the center, like a square on the top. Look at here. You get a piece like this, isn't it? You mark a square and cut it towards the center. If you take out the piece will be like this. If the total area of the solid sphere is A, the smallest area what we have taken on the top, that will be dA, small area. What is the dA? Small area. And this is what a radius of the sphere. Yes or no? So this is the radius, and this is radius, and this is radius, and this is radius. Okay? And all these four sides will form, or this small area will form an angle at the center. So that is the angle called solid angle, which is denoted with the symbol d omega. Like plane angle theta is L by R, so d omega is equal to dA by R square. D omega is how much? dA by R square. Carefully see, it's a formula here. What is, how the formula for the plane angle? Plane angle is equal to length of the arc by radius. The same way, solid angle is equal to area. What is a small area we have considered by square of the radius? What is that? Square of the radius. You understand? Here also there won't be any dimensions. Why? Because area, meter square, R square, meter square, the units of area, meter square, units of radius, meter and it's square, okay, because it's R square. Meter square by meter square cancels. Now the units are getting cancelled there in both the numerator and denominator, so it will never have the dimensions. Angles will have no dimensions, but it will have, as it is a fundamental, I'm talking about, as it is a fundamental quantity, it will have a unit. But when you come to the concept of numerator and denominator, both will get cancelled here, so it will have no dimensions. Okay? Clear? So this is the concept about supplementary physical quantities also. Now let's focus on the dimensions. So my dear students, the most important part of this session is dimensions and dimensional formula, which is the heart of this chapter. And I have told you during this first session of this chapter, you will definitely get a question on this, not exactly on this formula. Applications of these dimensions will be there at the last of the chapter. Applications from here, so definitely you will expect a question. I can say 99.9% there will be a question in the NEET exam or JEE exam or CET exam based on these dimensions. The application. To apply the concept, you must know the basics, and these are the basics. Okay? Now, what is a dimension? What is a dimension? And before moving to that, you know the dimensions of the length. It's L in square brackets. Dimensions of the mass, it's M in the square brackets. And dimensions of the time, it's T in the square brackets. Most of the chapter, as you are just starting your first PUC and we will be considering these three physical quantities and these dimensions only in this class. Not only in this class, in most of this chapter. These three quantities only we will be using. Most of the times, okay? Now, what is a dimension? What exactly the dimension? I'm telling you, listen to me carefully. Most of the students, and you can also see when they come to the class and you can also compare with your friends. Most of the students will answer the dimensions concept correctly without having a proper knowledge about what exactly the dimension is. They know the length is this one, mass, dimensions. Dimensions they know. Dimension formula also they know, but they don't know what exactly the dimension. You ask what exactly the dimension is. 99% of the students will fail to answer. But you should not be in that 99%. Okay, so that's the reason, the basic we are starting here. What is the dimension? Remember, look at this here. Dimensions of a physical quantity. See, any physical quantity will have the dimension. That's what I'm writing. Dimensions of any physical quantity are the powers. Dimensions are the powers. That's it. Dimensions of a physical quantity are the powers to which the fundamental or base quantities raised to represent a given physical quantity. That's it. It may be a new terminology for you, but it's so easy to understand. Look at here. Dimensions of a physical quantity are the powers to which the fundamental quantities are what? Mass, length, time, electric current, luminous intensity, thermodynamic temperature and amount of substance. Clear? Those 7 are the fundamental quantities. That's it. So, dimensions of a physical quantities are the powers to which the fundamental quantities are raised to represent a given physical quantity. With an example, you will understand it 100%. And let's see about the example. Forget about the dimensional formula. A small example let's take. So, the small example is acceleration. Acceleration is equal to, what is the formula for the acceleration? The change in velocity divided by time. Change in velocity. In the numerator I can write velocity is equal to a displacement by time. Velocity is what? Displacement by time. So this is the numerator and denominator is also the time. Okay, what I am doing here, I am just doing the representation of acceleration in the fundamental physical quantities. So the acceleration is equal to, what happens here? Acceleration is equal to displacement I can write in the length, because displacement is a length, divided by time. So it is a numerator. And this denominator is time by 1 here. This, if I take to the numerator, that will be 1 by time. So what is the acceleration here? Carefully see. The acceleration is equal to length, right, divided by time square. Understand? So this I can also write it as length into time whole to the power minus 2, because time square goes to the numerator, that will be time minus 2. So here nothing is there, I can write length to the power 1. Understand? Clear? But there are three physical quantities here. If you want, I can also write the mass here into mass to the power. Actually, mass is not there. But still, if you want to include the mass, it is 0. Anything to the power 0 is 1. Anything to the power is what? 1. Sorry, anything to the power 0 is what? 1. So this is 1. No need of mentioning it, but still, I have mentioned it. Okay. Clear? So, what we are going to conclude here is acceleration is a physical quantity, maybe a fundamental or derived, whatever it may be. Anyway, if you write the fundamental quantity here, that will not be depending on any other physical quantity. 100% this must be a derived physical quantity. Okay, so this is the acceleration, which is a derived quantity, is depending on length, time and mass. Okay, first thing, how it is depending? To represent the physical quantity acceleration, the length is a fundamental quantity which is raised to the power 1. To represent the acceleration, time is a fundamental quantity is raised to -2. To represent the quantity called acceleration, the mass is a fundamental physical quantity which is raised to 0. Okay. To represent the quantity called acceleration, dimensions of the length becomes 1, dimensions of the time -2, dimensions of mass 0. Okay. Now, you can write the dimensional form. This is about the dimension. Dimensions are what? Dimensions of a physical quantity are the powers. Dimensions of the physical quantity are the powers up to which the fundamental quantities are raised. See here, fundamental quantity is raised to the power 1. Fundamental quantity is time, which is raised to power -2. Fundamental quantity is raised to the power 0. To represent a given physical quantity, I hope you got 100% clarity and clear picture based on what exactly the dimension is. To represent the physical quantity called acceleration, length is raised to the power 1, that's called the dimension. Time is raised to the power -2, that's called the dimension. Mass is raised to the power 0, that's called the dimension. Understand? So now the dimensional formula comes into the picture here. Dimensional formula. What is the dimensional formula here? Look at this carefully. A dimensional formula of this, I can say the acceleration length dimensions are what? L. L to the power what? 1. Okay. And here, time to the power what? -2. Okay. So here mass to the power is what? 0. These are the dimensions. So if you write all together, look at here, it will be acceleration, and in square brackets if I write what? Dimensions we are writing, acceleration, which is equal to here. All together you can write, so m to the power 0, and this is L to the power 1, and this is t to the power -2. What is this? Dimensional formula. What is this complete thing, or this part is called a dimensional formula. So, hope you understand what exactly the dimensions. What is the dimensional formula? Okay. Here m to the power 0 you may or may not write, not necessary to mention, or if you mention also no problem. So the acceleration dimensional formula you can write L t -2. I can write it this way also. L to the power 1 or L, it's same. Alright. So to represent the acceleration, which is a physical quantity, the base quantities are raised to some powers. Mass is raised to the power 0, length is raised to the power 1, time is raised to -2 to represent the quantity called acceleration. Okay. To write any dimensional formula you should know the physical formula. Remember, any dimensional formula, if you want to write, you should know the physical formula. For example, so many physical quantities we are going to write here. For example, we are going to write the dimensional formulas here. Listen, physical formula you should know, right? First, let's take simple. Speed is equal to dimension. The question is dimensions of, or the dimensional formula of the speed, right? Speed is equal to what? A distance divided by time. So this distance is equal to length divided by time. So here I can write, so dimensional formula of the speed is equal to length is L, alright? So divided by dimensions of length. Time dimensions are T. So this is L. If this T goes to the numerator, it will be T minus 1, right? So finally, dimensions of the speed, what is that? Which is equal to LT minus 1. Okay, this is the dimensional formula of the speed. So mass I have not included here. If you want to include the mass, it will be M0 L1 T minus 1. That is also correct. Okay. You know what exactly meant by m to the power 0? M to the power 0 or no mass expression here that indicates speed of a physical quantity is independent of the mass. It is depending on the length and time. That's it. Here also. In acceleration also you can see there is no mass here. That means acceleration of a quantity of an object is independent of mass. M to the power 0 means independent of the mass. If you get L to the power 0, that means that that particular physical quantity will be independent of the length. If you get T to the power 0, that particular physical quantity will be independent of the length. Right? Other than zeros, if you get some powers which are raised, so then that means they are depending on those physical quantities. Okay? Clear? And let's write some more things. So let me write area. Area is equal to, for example, area of a square or area of anything, right? It will be, for example, square length into breadth. Both are lengths only, right? Length into length you can say. So the dimensions of area will be, length dimensions are L and the another breadth dimensions are also L, because it is also a length. And I can say it is L square, and I can also write M0 L to the power 2 and T to the power 0. So dimensional formula of area is what? M0 L2 T0, because area of any surface or any object you can say it is independent of its mass and time. Yes or no? Independence of its mass and time. In the same way, you get dimensions of volume. Volume is what? Length into breadth into height, or length into length into length, and which is M0 L to the power 3 and T0. Understand? You get like this. Well, my dear students, see here. So there are 6 physical quantities I have taken. We are going to, all these 6 physical quantities are derived physical quantities. Clear? All these physical quantities are derived physical quantities. All right? And we are going to write the dimensional formulas of them. What is that? A dimensional formulas of them. Formulae. Okay. The quantity we will consider first, then its physical formula we will write. See, remember that. Quantity, physical formula, then the dimensional formula. So after that, this physical quantity unit, so which is SI unit, and whether it is a scalar or vector, we are going to write. Then the complete 360 degrees approach will be finished. What are the things we are going to write and discuss about each physical quantity? First, what is the quantity we have considered and what is the formula of it? That means the physical formula of it and the dimensional formula of it and SI unit, and finally scalar or vector will be doing it. Number one, what is the first physical quantity? Let's consider the force. What is the formula for the force? Physical formula: force is equal to a mass into acceleration. Clear? Force is equal to mass into acceleration. What are the dimensions of mass? It's m. What are the dimensions of acceleration? We have just previously discussed, but still we will be doing it once again. Listen to me carefully. So mass into acceleration. I'm writing mass into acceleration is what? Change in velocity divided by time. Okay. And this I can also write mass into velocity is a displacement by time into 1 by time. See, velocity is displacement by time into this time is there, 1 by time. So completely I can write force is equal to mass into, so this displacement into 1, I can write its length divided by time into time. It is time square. Okay. No confusions. What is our aim? To find the dimensional formula, we need a physical formula. Yes, physical formula we have, and all these quantity completely must be written in terms of the fundamental quantities. Because the definition of the dimension is like that. Dimensions are the powers to which the fundamental quantities are raised to represent the given physical quantity. Right? So what is that? Mass m. Okay, into length L divided by T square. Okay, so what I can write? M L, T square goes to the numerator, that will be T minus 2. Is it okay? What are the dimensions of the force? M to the power 1, L to the power 1 and T to the power minus 2. That means to represent the physical quantity called force, mass is raised to the 1 and L is raised to the 1 and T is raised to minus 2. Okay, clear? Now, let's take the second physical quantities. I hope you understand the situation. Second quantity is density. It's so simple. Density formula is a mass by a volume. Mass, physical formula, sorry, dimensional formula is m. Volume, dimensional formula in the last slide we had discussed L to the power 3 because length into breadth into height. So now it's ml minus 3. See, ml minus 3. So if you want to write in terms of mlt, m1 L minus 3 T to the power 0. That's it. This is the dimensional formula of density. Now, a dimensional formula of pressure. Before moving to that, we have missed two important things. Quantity formula, dimensional formula. Fourth step also unit. What is the unit of the force? It's Newton. What is the unit of this density? What is the unit of density? See, mass is kilogram by, what is the volume? Meter cube. Okay. So, scalar or vector? Force is a vector quantity. Density is a scalar quantity. That is also we have to do. Thereafter, that complete perfection will come out. Pressure is equal to, you know, from the lower classes you are learning, pressure is force per unit area is a pressure. And this force dimensions, you know, the force dimensions already we have M1, L1, T minus 2 divided by area. Area dimensions are what? L to the power 2. Length into breadth. The last slide we have done it. So this can be written as M1, L1, T minus 2 into this L to the power 2. When it goes to the numerator, it will be L to the power minus 2. Okay. And you know how the powers will be added up. Right? Powers will be added up, you know. For example, a to the power 2 into a to the power minus 1. So it will be a to the power 2 minus 1. It will be a to the power 1. Understand? So a to the power 5. A is a physical quantity. A to the power 5 into a to the power 2. It will be a to the power 5 plus 2, which is equal to a to the power 7 is the correct answer. According to this mathematics, I can write here m to the power 1, L to the power 1 into L to the power minus 2. So that will be L to the power 1 minus 2 into T to the power minus 2. And the final value, final dimensional formula is L to the power 1, sorry, M to the power 1 and L to the power minus 1 and T to the power minus 2. Is it clear? Sure? Confident? Fourth, shall we move? Before that, pressure. What is the unit of the pressure? SI unit of the pressure is Pascal. And pressure is a scalar quantity. Right? Now, fourth physical quantity is work. Work. Fundamental quantity we had considered. Work is equal to force into displacement. Last basics. Force into displacement. This I can also write force into length, because displacement is a length. So dimensions of the work, I can write dimensions, a dimensional formula of the work will be force. What is the force dimension? Force dimension is available here, m to the power 1, L to the power 1, T to the power minus 2. Okay. Into, right, into displacement. Displacement is L. L means L to the power 1. Here you can write m to the power n. L to the power what? L to the power 1 into L to the power 1. So I can say L to the power 2. T to the power minus 2. So that is a dimensional formula of work. Fifth one and sixth one, you have to do it. What is the fifth one? Linear momentum. What's a linear momentum? Mass into velocity. Yes or no? Linear momentum formula is what? Mass into velocity. And before that, work. SI unit is joule and work is a scalar. Linear momentum. Mass into velocity. Mass dimensions, you know. And velocity dimensions also we have done somewhere here. Velocity, yes. Displacement by time. Okay. Mass into velocity, you do it, you will get the dimensional formula. Clear? And it's SI unit you know, and it is a scalar or vector also you know. And the sixth one is kinetic energy. What's the formula here? Half into m into v square, and here you will understand the situation. 1 by 2 will not have any dimensions. Only the physical quantities will have dimension. 1 by 2 is not a physical quantity. It's a numerical constant. 1 by 2. Wherever you take this 1 by 2, its value is 0.5 only. That means it's a numerical constant. Right? So these numbers will not have any dimensions. So you need to consider only m into v square. So that will be mass into velocity square. So you know the mass dimensions and you know the velocity dimensions and it's square. So you get the dimensional formula here. You will get the dimensional formula here. Right. So you have sufficient time to revise these dimensional formulas. Prepare well and write your assignment properly. Okay? Clear? And this is the basics of the applications. We'll be discussing about applications. I told you that that's the most important part of the session. To understand and to answer the applications properly, and these basics are very important. Right? And after the assignment, I'll be giving you so many physical quantities. You should come with the proper answers. You should send me the proper dimensional formulas of those physical quantities, right? I'm not going to give you the new physical quantities for you, like a first time listening physical quantities. I'm not going to give you. The quantities what we had discussed in the previous classes, only those quantities, dimensional formulas only you should write and send me, and those list of dimensional formulas what I need, I will be giving you as an assignment. It's a home assignment, right? All the very best.